All right, now we're going to move on. Yesterday we talked about volume of prisms and cylinders. And now we're going to talk about the two other ones that we need to learn about. And it's interesting because cones and pyramids are kind of part of cylinders and prisms. In other words, they can kind of, they're not as large, they don't hold as much, and they can actually, the formula actually kind of indicates that. So the first shape we have here is obviously a cone. Now, if you look, you can actually see where if we actually extended this out, right? So it only has one base, but if we extended this out, kind of, and then kind of increase the base a little bit, it would actually be a cylinder. So it's not going to hold it obviously as much as a cylinder, um, and that's going to be, that kind of figures in to the formula. The cones and pyramids, another place that they differ are the number of bases. As you can see here, cones have just, okay, just one base, as do pyramids, and they have kind of, it comes to an apex there at the top, a vertex, kind of where it. Okay, so we're going to figure out the base, but then it kind of comes into play in the formula a little bit. So we said a cone has a circular base, okay, and then we have the formula. The formula sheet has for your cone 1/3. Remember now, here's how it differs. The radius is the height. So the radius, remember, okay, the radius and the height. So from there to there on the base is the radius. And then here's the height. Remember we talked about this in the Pythagorean theorem. It's not the slant height. It's from the middle of the base where that radius is to the top of the cone there, or bottom, depends on how you're looking at it. Usually it's going to sit on its base. But normally when we think of a cone, like an ice cream cone here, it's going to sit this way. So this is going to be R, and that's going to be the height. Okay. So as you can see, what's one other thing I want you to notice here, and what's going to have to come into play, is that we have this right triangle there. Okay. See that right triangle? So we're going to have to use the Pythagorean theorem to sometimes figure out the height of these things. So don't be shocked when we have to do that. Okay. All right. There we go. All right. So we have radius here. We have height here. I'm trying to figure out the base, which is this part right here. Okay. And we have to use the height. So what do we know about a circle? The area, right, of a circle, okay, is pi r squared, right? Okay. And then the height, but that would be back to the formula for a cylinder, right? So this is not as big as a cylinder. It doesn't hold as much. And we're actually going to do a little kind of experiment when I get back in class to show you where we get this. A cone is 1/3 as big, okay, as a cylinder. Okay. Why is that going to follow me around? Why is it following me around? I'm not sure where. Oop, not sure where that guy's coming from. Sorry, guys. All right. We're just going to have to live with them right now. So here's the formula. 1/3 of the area of the base. Okay. Wow, it's going haywire on me. All right, sorry. All right, 1/3 the area of the base, right, times the height. Okay, pretty simple, right? So we're going to take the area of that circle, divide it by 3, and then multiply it by the height. All right. The volume of 3 cones can fit in a cylinder with the same base and height. That's important. That's where we get that 1/3 from. We just take the cylinder, divide it by 3. Okay, so it says find the volume of a cone, no pictures, find the volume of a cone with a radius of 13 and a height of 5. So again, Obviously, it's a cone. All right, find the formula. The formula says it's 1/3 times the area of the base times the height. Okay? Now we're going to substitute in the values. In this particular case, we're going to start with 1/3. That's always a constant, always the same. Pi is the same. Radius is 13, okay, and a height of 5. All right, so let's scroll down here a little bit. So in our calculator, let's do 1/3. Let's say pi for dessert. Let's go 13 squared, which is 169, times 5. Okay, let's take, let's do 169 times 5. Remember, it's all multiplication, so it doesn't really matter what order. I like to say pi for dessert. All right, times 845. Now I'm going to multiply these two next. Okay, and multiplying by 3 is the same as multiplying by 1/3 is the same as dividing by 3. So let's take 845 and let's divide it by 3. Okay, so that's going to give us 845 divided by 3. That's going to give us 281, and I'm going to round here, times pi. Okay, and I'm going to multiply that by 3.14 in your calculator, and you're going to get approximately 884.4. All right, if you got a little something different, your little decimal or whatever, that's fine. Inches, still volume, cubed. Okay. All right, so let's go to a pyramid, which can get pretty tricky. All right, because we're gonna have two different shaped bases, as you see up here. We're gonna have a triangular shaped base, and we're gonna have a rectangular or square base. Okay, but they're only going to have one base. The lateral, meaning on the side, faces are triangles. So in other words, what they're saying here is the lateral, the base, let's do the base, and we'll do a different color here, right? Base is a square, or a rectangle in this case. I'm not sure which one, we don't have the measurements. And then the faces are the lateral, they are triangles. Okay. So these triangles are also called faces. There's one back here, right? One back here, I already got that one. So there's faces. The faces, there's the same number of faces as there are sides on the base. Okay, so one here, one here, one here, one here. So there's 4 triangles that make this up. On the rectangular one, it's kind of hard to see. There are 3 sides. Okay. Again, we say the shape of the base is used to name the solid. Cylinders and cones have circular bases, so we don't really call them by their base names. Prisms and pyramids we do. All right, so this is a square pyramid, a rectangular pyramid. So the volume, again, is 1/3. See, the base may be square, rectangle, or triangle. This is important. All right, those are going to be the 3 kinds of pyramids that you have. So look, here's big B again, right? Right there. Area of the base times the height times 1/3. Again, 1/3 is large as a prism. Okay, and why does this come in play? The area of the base comes in play because because there are different kinds of bases, which means we'll have to use different formulas. For a rectangle, square not so much, but the triangle and these two will have different formulas. Okay, so let's take a look at it. All right, so find the volume of the following image. So it is 4 and 4, which means it's a square pyramid, right? Square base, 4 here, 4 here, that means this is 4 and this is 4. So the formula, again, let's go, the formula, we can go back up, or you can look at your formula sheet, you don't have to memorize it, is, remember, it's a third as large. Cones and pyramids are a third as large as prisms and cylinders. Big B, area of the base, times the height. But let's rewrite the formula with the shape of the base. 1/3, what is the shape? Well, the shape is a square, right? It's a square base. So on your formula sheet, if you look at a square, it's s squared. Sometimes that's length times width, right? Same as a triangle, it doesn't matter because you're multiplying. So we get 1/3, and what's 4 times 4? So it's going to be length times width times the height. Now we're going to substitute it in. 1/3 is a constant, stays the same. We get 4 times 4. Again, remember the height is here. From the bottom, that is the height. Okay? The slant heights will come into play on surface area. And it might come into play when you have to find the height. But right now, that is the height. So, and it even labels it for you right here. Height is 9, which is good. So then we're going to go 1/3 times 16 times 9. Now here's what I'm going to do. And here's what I want you to guys eventually get to. I can look at 1/3 and 9 and go that they can be, 3 can go into 9 evenly. So I'm going to do those two first. You don't have to. You have a calculator, but I'd just like you to be able to go, well, 1/3 of 9 is 3, and 3 times 16, and that's going to be 48, correct? Anybody check my work here. 48 centimeters cubed. Okay? All right, so let's look at example 3, word problems. We're going to have some story problems in here. Actually, a lot of them in this unit. Imagine a warm summer day and you want to pack an ice cream cone with ice cream. If the cone has a diameter of 3 inches and a height of 5, what's the volume? Remember what we talked about before. Let's draw a picture. Okay? So it says diameter, which is what? All the way across. That's the diameter. And the height is from here to here. The height's important, right? Or all the way down here. That's 5. Or we could say it's in here. Like that big one. There we go. We can go from here to here's the height, right? Same thing. And remember, they gave us diameter, but what do we need for the formula? Radius, right? I don't think that color doesn't work well here. Radius, we only need that. So if the whole thing is 3, let's use blue, what is each one? 1.5, 1.5, right? But we don't need the other one, we just need one of them. So, obviously, it is a cone. Now, we said the formula, because it's only 1/3 as big as a cylinder, is 1/3 pi r squared times the height. Right? So let's plug it in. 1/3 pi, what's the radius? 1.5 squared times the height is 5. Alright, so let's do 1.5 squared first, which is 2.25. Times 5. Alright, so let's do it in your calculator. Times 5 divided by 3 times 3.14. So I'm going to get 11 point, I'm going to round that to 78 inches cubed. Okay, so I just went ahead and did it in my calculator. I did 2.25 here, times it by 1/3, and then times 3.14. So try that in your calculator and make sure you get that. You can certainly multiply all these straight in a row. Doesn't matter. You should get the same answer because it is multiplication. Okay. So remember, word problems, draw a picture. I mean, it doesn't have to be perfect. Obviously, mine's not. But just so you can get a reference of what the height is, what the radius is, and diameter. All right, let's look at this one. The volume of a pyramid with a rectangular base that has a width of 6 feet and a length of 4 feet and a height. You know, a picture might even be a little bit more, I don't know, it might even be confusing. All we need to be concerned with is this, okay? Rectangular base, super important, okay? Because it tells you a width of 6, a length of 4, then it says we got a height of 3. That's all we need because the formula tells us that it's 1/3 area of base, big B, times the height. All right, so let's identify the shape. So it's a rectangular pyramid. Okay, the formula says 1/3 big B times H. Now, since this big B, remember, big B means area of base. So that's going to be 1/3. And what shape is the base? It's a rectangle. So it's going to be length times width times height. Okay? Now we're going to substitute in those values. So you're going to get 1/3, 6 times 4, and a height of 3, which is going to equal 1/3, 24 times 3, and these are all, that's a 4 there. My writing's terrible. 4. Okay, so 24 divided by 3 I know is 8, and 8 times 3 is 24, but I could have done 1/3 of 3 is 1, and 1 times 24. Okay, so I get 24 feet cubed. Now, I could have drawn, and I am not good at these guys, okay? Okay, the pyramid there, 6, 4. Remember, the height is here. The height is here, right down the middle to the middle of this, and that was 3, okay? But this might almost be more confusing when you have to draw a pyramid. If it gives you the base and the length, you just find the area of that base, big B, okay, which is 6 times 4. They gave us the height here, which is 3, and 1/3 is part of the formula. All right. Go ahead and show sub your notes and grab your work, classwork, if you're finished, homework if you need to. If you need to finish this at home, that's fine. Just make sure you grab that, try to work on it over the weekend. Hope you have a good weekend, and looking forward to seeing you on Monday.